Have you ever wondered why astronauts in space age slower than people on Earth? This intriguing phenomenon is largely due to what we call time dilation. Essentially, time dilation is a difference in the elapsed time as measured by two observers. Now, these observers could either be moving relative to each other or could be situated in different gravitational potentials. This concept, which sounds like it's straight out of a science fiction novel, is actually a prediction made by Einstein's theory of relativity. You see, Einstein suggested that time isn't a constant universal quantity. Rather, it can stretch and squeeze, warp and weft, depending on the gravitational environment. This means that time can pass slower in places with less gravity, such as space, compared to places with more gravity like our very own Earth. So, time and space are interwoven, bending and stretching in response to mass and energy. But how does this affect our astronauts? Imagine yourself as an astronaut floating in the vast expanse of space. In this boundless, weightless world, something extraordinary happens to time. It's a phenomenon called time dilation, a key concept in Albert Einstein's theory of relativity. Time dilation refers to the notion that time passes at different rates in different gravitational fields. Picture this. You're aboard a spaceship cruising at a significant fraction of the speed of light. Outside your window, Earth spins in its steady, graceful dance. Inside your vessel, you have a clock ticking away the seconds. Now back on Earth, there's an identical clock. But here's where it gets intriguing. Your clock, the one on the spaceship, ticks slower than its Earth-bound twin. Yes, you heard that right. Your time is moving slower. This isn't some science fiction trope, it's a scientifically observed effect. In the weaker gravitational field of space, the astronaut's clock, and thus the astronaut themselves, would age slightly slower than those on Earth. Now, before you start dreaming of the cosmos as a fountain of youth, let's add some perspective. The effect is incredibly minuscule. Astronauts aboard the International Space Station, for example, would age slower, but only by about 0.007 seconds for every 6 months. It's not exactly a ticket to immortality, is it? But it's still a fascinating thought. For those astronauts living among the stars, they're literally living in their own unique slice of time, a fraction of a second removed from the rest of us. It's like each astronaut carries a piece of a cosmic time puzzle, a puzzle that challenges our understanding of the universe and our place within it. It reminds us that time and space are intertwined in ways that can seem almost fantastical, yet are fundamentally real. So does this mean we've discovered the secret to eternal youth? Not quite. But we've certainly uncovered a fascinating quirk of our universe. And who knows what other mysteries are waiting out there in the silent expanse of the cosmos. While the concept of time dilation is fascinating, it's not as dramatic as some might think. Yes, time does run slower for astronauts in space compared to us here on Earth, but we're talking fractions of a second, not years. Imagine a twin astronaut who embarks on a year-long space mission at the speed of a typical spacecraft, while their sibling stays behind on Earth. When the astronaut twin returns, they would be just about 20 milliseconds younger than their Earth-bound sibling. That's not even enough time to blink an eye. So why is the difference so small? Well, it's all about speed and gravity. The effects of time dilation only become pronounced at speeds approaching the speed of light, or in extremely high gravitational fields. Given our current technology, humans are nowhere near capable of achieving such speeds or experiencing such intense gravitational fields. The fastest spacecraft ever launched by humans, the Parker Solar Probe, travels at around 330,000 kilometers per hour. That's incredibly fast by our standards, but it's only about 0.03% of the speed of light. To experience significant time dilation, we would need to travel at speeds much closer to the light speed. Similarly, the gravitational fields that humans can currently experience are far too weak to cause noticeable time dilation. Even the most massive object in our solar system, the Sun, only slows down time by about 33 seconds per year at its surface compared to Earth. So, while our astronauts may get a tiny bit of extra time out among the stars, it's not enough to turn them into time travelers. But it does make for an interesting thought, doesn't it? The reality of time dilation is not as sci-fi as we might imagine, but it's still a fascinating phenomenon that pushes the boundaries of our understanding of the universe.